GAC, it's Coach Jay, Chapter 8 today. Hope you're doing well on the night before spring break. Wow, can't believe that we're already at this point. Man, I hope everything's been going good for you as we transition over here to our last little bit. As we continue forward on some of these problems, if you have questions on any of these, you can feel free to text me, and we'll go over those together. Also note, I am going to go through each type of problem, try to discuss, hey, what type of formula you would have, and then also discuss things that I would recommend maybe even putting on the review sheet or putting on the your formula sheet as well. If you end up watching this too, I'd love for you to text in, and that way I just know who is here, and that way we just kind of have an idea of the people who showed up as well. All right. Without further ado, let's get started on our last, wow, I can't believe this. This is our second to last podcast as far as a study session, so I can't believe it. So let's get it started, and I'm going to start on number 1, but if you text me in on a different one, we can go from there. Also, just a quick note, I wanted to also mention to you that all of the problems that we're going to do off of either A or B. So if it's the first one, state A, and if it's the second one, you could state that it's B. I do want to do the B version because I believe this is the only one that when I checked was wrong on the answer sheet when I had done that there. So if you want to check that out, that might be a good one going forward. All right, on your review sheet, you'll notice that in the top left, you have the arithmetic formulas, and in the top right, you have the geometric. Now, in this case, a lot of times you're going to see that literally the wording will give away what formula you use. For instance, find the sum of the first 14 terms of the geometric sequence. Understanding that we have two different types of formulas. First of all, we have a formula that is, I'm sorry, not n. We have the sum of n, right? S of n, where one is a1 over 1 minus r, and the other one is a1 times 1 minus r to the n all over 1 minus r. Now, if I have a finite number, that means I have a finite value, maybe 12 terms, 13 terms, whatever. I'm using this first one. And if I have an infinite, if I state that it's infinite, we'll use the second one, okay? Now, a couple things to note too. If you start feeling lagged, like if it's lagging behind, please let me know so that I can adjust the Wi-Fi. We've been having some issues with that. So please let me know, text me if anything is wrong with that, okay? All right, perfect. Now, in this first example, you'll notice that on the B version that we have 14 terms. Therefore, it's a finite number. So we're going to use our first equation. So when we use this first equation, what's important about this is what's been given. For instance, we know there's 14 terms. A note that I might put on the side is that n refers to either like the nth term, like the second term or whatever that may be, or when dealing with the sum, it's the total terms, total amount, okay? So depending upon what you're looking for, it could be either one of those two in arithmetic and geometric. So we know we could plug 14 in for n. So S of 14 equals, and as we keep going, we notice that 3 is A1, so we could plug that in. And R is 0.3, so we could plug that in as well. So we have 1 minus 0.3. And 0.3 is going to be to the 14th power all over 1 minus 0.3. Now, a important part of this, and I'm going to kind of pull this up, see if I can actually share this here, because I think it'll be that big of a deal. I'm going to pull up my TI calculator here, because as I was talking, I think I was talking to Maddie this afternoon, and I was telling her specifically on these problems, you have to make sure you do use order of operations. If you don't, man, it can be a struggle a little bit for solving these. So let's do this. Let me see if I can get the screen here. Hey, what's up? Sorry about that. Can you do this? Go to this one. Perfect. All right. So if you go to y equals, and actually on this, actually not y equals, I apologize. That's a different one. We'll actually do that one next. But if you go to this value, what you want to do is first put in 0.3 to the, let's make sure we have the caret, to the, and what power was it again? I believe it was the 14th. Let me make sure. It was to the 14th. Very good. So we got 0.3 to the 14th there. And if there's a negative, make sure you put that in parentheses, like negative 0.3. But because the negative's on the outside, you don't have to. So we're going to press enter there. Then I'm going to do 1 minus my answer. So second negative gets me that next value. So it's a really small decimal, or really big decimal. I guess you could, either way. So we got this here, closing in on 1. Then we're going to divide this by, 1 minus 0.7. We could do that in our head to get 1 minus 0.3 is 0.7. We can do that in our head. So we're going to divide that by 0.7. And then we're going to multiply this by 3 to get our ultimate answer of 4.29 rounded. And so again, when I'm looking at something that is like this, what I'm trying to do is we're trying to come up with what is the sum of this finite sequence. And so that's what we would be looking for on this one. Okay. All right. That's number 1. And again, I'm not getting any text in, so I'm assuming that everyone's good on that, but we'll continue forward. And if you still have questions, then you can let me know. On number 2, let's look at number 2 here. On number 2, it's very similar. The only difference on this one is you have to kind of notice that the second one is geometric, not based on the wording, but based on the formula. But you notice that it's the sum of the first 10 terms. So if I'm finding the sum of the first 10 terms, it's still finite. Therefore, we're going to plug it into this formula. Now, since we already know or have an idea of what's going on, I don't want to go through too much. But what I can say is that we know that the A1 term would be 12, where the rate would be negative 1/2. Okay? And yes, I'll do number 9. I'll come to number 9 here in a second. So let's plug into this value here, S of n. And we know that it'd be S of 10 equals A1, which would be 12, times 1 minus negative 1/2 to the n power. Again, n is 10 because that's the total amount we have, all over 1 minus negative 1/2. Now, down below, we can make this positive because there's no power that ends up changing that. But please do not make this positive. The reason why is you first must take negative 1/2 to the 10th power and then do 1 minus that. So once I do that, it'll be negative 0.5 to the 10th power, 1 minus that answer, divided by 1.5, and then all multiplied by 12. So that's how I would get to there when I solved for that moving forward. Okay? All right. So overall, I've done number 1. I've kind of done number 2. And we can kind of always come back to that. I just saw someone post here, or just a text there, that we need to do number 9. And what we're going to do, let's do 9B, okay? All right? Yeah, and we could do the A problems. That's a good point. Let's do the A problems because a lot of the B ones are on their answer sheet, so you can kind of mimic that. The only thing on 9B, make sure you make that x squared y to the 3rd. Whereas this one, make sure the A1 is x to the 3rd, y to the 4th, because it got messed up when we did that there, okay? So that's what we're trying to find. Now, I told you that a lot of these problems are linked closely to the test, so they're going to be asked very similar to this. Now, on your formula sheet, it states that it's x to the n minus r and y to the r power, okay? Because, again, that's kind of what we're using. So when I do the NCR, to be able to find the coefficient that starts off in front of this, we can know what the r is based upon what the power of y is. So y to the 4th would be obviously that r. So that c would go in place with 4 on the right side. Now, as far as the n is concerned, n is the largest power, which should be to the power of 7. So 7c4 is what we would have as our coefficient to start this process. So when I do 7c4, I should get, and I want to make sure, I think I get 35 is what I remember getting there. And you could do that on your calculator, 7c4, by going to the math button, PROB, which is text language for the probability. And then you can go to the bottom, or I believe, or middle is the NCR. So we get 35. X to the 3rd, y to the 4th. Now, if I had x plus y to the 7th, this would be my answer. However, the problem is that 2x is in place of x and negative y is in place of y. So to find this completely, what we have to do is we have to solve this by doing 35, parenthesis, 2x to the third, parenthesis, negative y to the fourth. So what we can do is 3 is going to go to the power, both powers. So 2 to the third is 8. And then we have x to the third. So we have 8x to the third with 35 on the outside. Negative y to the fourth would be just y to the fourth. So I have 35 times 8, which should be, I think, 270. X to the third, y to the fourth. So that would be my complete answer. Notice this is positive because it's to an even power. So just a heads up on that and moving forward. Okay. You may want to do this next one with x squared y to the third. Remember, once you found what your coefficient was, remember NCR, this should be 5C3. Remember, I plug in 3x in for x here, so that'd be squared, and 2y will be plugged in for y, okay, because that's the second part. So there, and this one goes with that, okay? All right, we got 9 there. Let's come back to number 7. All right, perfect. This one says, this one's a little different. Find the sum of the infinite geometric sequence. Well, remember, we already looked at what finite was, right? Finite was this formula right here. So when we talk about infinite, infinite is S of n equals A1 over 1 minus R. Now, in this example, it doesn't come out and say that. It doesn't come out and say like what it is. But we do know that the first term is -6 because that's the first one given. So we plug in -6. 1 minus. Now, R we don't know, and this can be a little bit tricky. But to kind of help us out, what we'd like to do is we can go from the first to the second. But remember, with geometric, we got to multiply by something. So maybe the first to the second may not be the best. However, if I look at the second to the third, I notice that it goes from negative to positive, negative to positive. So I know my ratio's got to be negative of some kind, okay? So it's going to be negative some kind. And from the second to the third, the top part multiplies by 5. So 5 times 5 is 25. And I know from 1 to 6, I can say 1 times what equals 6. And I know that it will be 5 over -6. So we could try it from the second to the, or from the third to the fourth. 25 times what equals 125, that's 5. And 6 times what equals 36, and that's 6. So our ratio, R, is -5 over 6 is what we multiply from 1 to 2 to 2 to 3, 3 to 4. Now to continue, we now have -6 over 1, and now we can add, right, because there's no exponent there. So order of operations allows us to do 1 plus 5 over 6. Now, not quite done because we want to get a common denominator. So we're going to put 6 over 6 here. And so we have -6 over 11 over 6. Flip this to the top to multiply by 6 over 11. So when we multiply across, we should get -36 over 11 as our answer. Or you could put like 3 point something there, and that would be completely fine. All right. All righty. I think that right there, that kind of covers this one. If you have any other questions, let me know. But we should be good to go on this one moving forward. All right, so we just flip it to the top. So we got, again, -36 over 11. Or you could put -3 what is that, 3.3, something like that, 3.3-ish, 3 something. Make sure it's 2 decimal places, but it's approximately that. You can do either or, okay? These are great questions. People are texting in here. I've got, again, man, I've got stuff all over the place, which is perfect. So continue coming with me with any questions you have. Trying to think. We did number 7 here. Ooh, yeah, 6. 6 is a really good one. 6 is a really, really good one. So let's look at 6. Now, it says write the first 5 terms of the geometric sequence. Now, since it doesn't talk about sum, the ones that say S of n are going to get thrown out because we're not really talking about sum. We're not finding the sum of something. So because of that, we can simply ease up on the difficulty by doing the A of n formula. And again, since it's geometric, we're going to do the one in the top right, which is A of n equals A of 1 times R to the n minus 1 power. Now, here's the trick. I don't know A of 1, but I do know A of 3. So there's a way we could solve for A of 1 by plugging in what we know. So we know R is 1/3. Okay. And as I plug in, I notice that, well, if A of 3 is 2, I could do this. I could say, let's let n be 3. So let's say a of 3 equals a of 1 times 1/3 to the, remember, n is 3, so we have 3 minus 1 power. But I still need something in place of this. So what we're going to do is we're going to place 2 in for it because we were given that a of 3 was 2. So now I've got 1/3 to the second power. 1/3 times 1/3 is 1/9. So I have a1 times 1/9 equals 2. To simplify, I'm going to multiply by 9, where 18 equals our first term, which is a of 1. Now, in a ratio, remember, common difference in arithmetic is adding and subtracting, right? Whereas in geometric, we're going to multiply by something that's continually like the same value, right? So in this one, we can multiply by 1/3. So 18 times 1/3 gets me 6. Times 1/3 gets me 2, which matches up with my third term being 2. We got that there. Multiply by 1/3 to get 2/3. Multiply by 1/3 to get 2/9. So my 5 terms that they wanted me to find were the following: 18, 6, 2, 2/3, and 2/9. Okay? Now on the second one, the only difference now is you would plug in 4 and for n and then go from there, okay? All right. Excellent. I just got a text with a bunch of numbers on it, which I very much appreciate because that allows me to be directed a little bit further on that one, okay? All right. Awesome. Let's go to number 8 because this one is a good one. All right. Yeah, y'all will like this one. Number 8 is one where we're trying to find the 23rd term. Now, there are 3 formulas, right, with geometric, and it tells us it's geometric. We have the 2 s of n's and then 1 a of n, right? Well, because I'm not finding the sum, just the 23rd term, all I need to do is we can eliminate the s of n formulas to say a of 1 times r to the n minus 1 power. Now, knowing that a of 1 is negative 23 and the rate r is square root of 2, we can plug in what we know to be able to solve for a of n part here. Now, because a of n, we're trying to find the 23rd term, n is always whatever term we're trying to find. So in this case, it's going to be the 23rd term, or 23. So we could state that a of 23 equals negative 23 times square root of 2 to the 23 times, or 23 minus 1 power, or we could just say 22. So what we're going to do is on our calculator, we're going to go and do square root of 2 to the 22nd power. Okay, so I'm going to come in here. Maybe you're doing it with me here. Maybe you're yelling just like Dora the Explorer at your TV. You know, like how you used to do back in the day. You know, maybe we'll have one where you have to yell at the screen there. So, all right, square root of 2 to the 22nd. We've got it. Perfect. I got 2048 is what I got. Then I'm going to multiply this by negative 23. Now, you probably got a pretty big answer, and you're probably thinking, man, that's really weird. But overall, I got negative 47,104. Okay, negative 47,104. And I used that one, and that was the answer I got for A. So negative 47,104. Okay? Awesome. So that was number 8. If you have any other ones, keep it coming. Let's look at number 11. Again, it says find the sum of the first 30 terms. Now, it is a finite number, so we know any infinite one, the geometric infinite one, the a1 over 1 minus r infinite one cannot be used because we have a finite number. Now, what is tricky is noting whether it is geometric or arithmetic. As I go from one to the next to the one to the next, one to the next, I notice that I'm continually subtracting by 1/2, making this a common difference. Well, what has a common difference? None other than my arithmetic formula there, or my arithmetic sequence. So because of that, since we're finding the sum, we're going to use our s of n equals n over 2 times a of 1 plus a of n. Now, what is n again? N is the 30. So s of 30 equals 30 over 2. And a of 1 is 1/2, so we're going to plug that in. And a of 30 is the last term, and that's a little different because this one, we don't actually know what a of 30 is. So we've got to figure out what a of 30 is, and this is very similar to the last problem on 22. To be able to solve for that, we've got to say that a of 30 equals, well, what's a of 1 plus n minus 1 times my difference? Well, difference is negative 1/2. N is 30, so 30 minus 1. A of 1 is 1/2, okay? And then we have a of 30. So let's kind of take this and go. So we have 29 times negative 1/2, which would be negative 29 over 2. And we have 1/2 plus this, so we get negative 28 over 2, which would be the same as negative 14. So negative 14 gets plugged in for a of 30, because that's the last term there. And once we solve for this, we end up realizing that it would be 15 times 1/2 plus, get a common denominator, so we put a 2 on the bottom, which puts a 2 on the top. So that would be negative 29 over 2 multiplied by 15. So when we kind of multiply this out, we'll go 15 times 29. And check me on this one, because I know it's a little bit off there, but I think we're on the right track here. Negative 20, or I'm sorry, this should be positive, shouldn't it? This should actually be negative 27, right? Negative 27 over 2. Negative 27 divided by 2, and multiply that by 15. And I got negative 202.5 as my answer. Okay, check that with me. Make sure we're all clear on that. But it looks as though we got that one completely right. So make sure on that. But again, we're finding the sum of the first 30 terms. And we did that right here by plugging into our arithmetic sum formula. And then finally at the end, being able to then identify what the sum was there. Okay? All right, excelente there. Great question. Great questions. Let's keep going. Let's see here. Oh, yes. Let's see. All right. Perfect. Let's go through 13. 13 here. Okay. So this one says find the first 5 terms of the sequence whose nth term is as follows. Now, you're going to really like this one. So let's do this. Let's go on a journey for a second. Take out your calculator, because I'm going to screen share this. Let's see here. Take that off. What's up, y'all? All right. Let's go to this one right here. I like this one. All right. Let's go to your calculator, and you're going to go to y equals, okay? Now, when you plug this in, you're going to plug it exactly the way that you see it on your study guide there. So we're going to put it in as, well, that's the way we see it. So negative 1. So we go negative. Make sure it's in parentheses, okay? Otherwise, you won't get it out. So if we're trying to find the first 5 terms, you could legitimately plug in 1, 2, 3, 4, and 5. However, a little bit easier is when we just plug this in, okay? Just plug it in. So we have negative 1 to the x power times 3x minus 1. So whatever you see there, if we're trying to find the first 8 terms or 5 terms, plug it in right there. Now, this next part, you should be okay on as long as you keep it consistent. If you go to second window, just make sure your table start is at 1 and your delta table or your change into your table is a value of 1. So 1 to 2 to 3, 4, 5, so on and so forth. Now, once you get to that point, go to second graph, and you'll notice that as you scroll down from 1 all the way to 8, you have your terms as x, so your first term, second term, third term, fourth term, fifth term, but all of your values on your output would be your y, negative 2, 5, negative 8, 11, negative 14. And those values would be what we're looking for those first 5 terms. So as you see it, negative 2, 5, negative 8, and 11, and negative 14 make this problem into one that's pretty easy and you can kind of do pretty quickly. Okay? All right here. Sweet. All right, let's see here. Next one is doing number 14. Let's do number 14 here. Make sure I can see it. All right. Now, 14 is one where we have to find a rule for the following sequence. Now, as I look at this, what I probably would do on all of these is determine what is occurring. For instance, both if it's a fraction, we could determine what's on top and bottom. Whereas in this one, you notice that from first to second, second to third, we're continually adding by 8. Well, if I'm adding by 8, I know I'm not finding the sum, so I could go straight to my arithmetic formula. A of 1 plus n minus 1 times d. Now, my first term being, and again, we don't need to know what the nth term is, or I mean, that's kind of what we're solving for. We do know that the first term is 13, whereas the d is 8. So when I distribute 8, I get 8n minus 8 with 13 added to it. Okay? So now we combine it together to get 5 plus 8n equals a of n. And if I were to plug in the second term or third term, it would match up to whatever I have here. So whatever you get as your answer, match it up, test it, and make sure that we're G to G, or Gucci, as y'all say nowadays, okay? All right, last thing. Notice on the top, there's two different rules, a rule for the top and a rule for the bottom. On the bottom, we're multiplying by 3 across, right? Now, since I'm multiplying by 3 across, you could actually go to your geometric and say that a of 1 times r to the n minus 1 would be what would be underneath. And you could do that, where the first term would be 3, the ratio would be 3, and it's to the n minus 1. You could also say that it's 3 to the n. Both of those would work, and both of those are the exact same thing. Now, the next thing is on top. One thing to notice is that it's 2 to the first, 2 to the second, 2 to the third, 2 to the fourth. So that makes it easy because you just know it's 2 to the n power. Well, because if you plugged in 1, that's what you would get, and so on and so forth. So you could either do that one, or you could do 2 to the n all over 3 to the n. And that right there could be your answer as well. Either one of these two. Okay? Butimus. All right, let's go to 17. Awesome. 17, I like 17 because, again, very pretty basic here because it's pretty self-explanatory. Find the 10th term, okay? Well, if this is the sequence, if I find the 10th term, all we're going to do is plug 10 in for n. So we'd say a of 10 equals 3 times 10 plus 4 all over 5 minus 2 times 10 plus 3. PEMDAS, my daughter's name. 3 times 10 is what we'll use. Get 30 plus 4 on top. On the bottom, we can combine inside to get 13 times negative 2. Make sure we don't subtract here because we got to multiply next to get negative 26. 5 minus 26 is negative 21. And 34 would be on top. So 34 over negative 34 over 21 is my answer for number 17. Okay. Similar to one we just did on number 13 or 14, I believe. Number 18, we're trying to find a pattern where we get to both the top and the bottom. Now, one thing to note is that this, again, is multiplied by 3 each time. So because it has a ratio, we could put the a of 1 times r to the n minus 1 power equation, and that might be helpful for trying to get that top there. Now, what do we do next, y'all? I want you right now, wherever you're at, to yell in your computer what you would do next. Very good. I hear you all over the place. Everyone, Sweden, all over the place. Sweden, London, Austria, Africa, Middle East, everybody, everywhere. So in this problem, we could plug in what a of 1 is on just the top. We're talking just top. We know a1 would be 3. Our ratio we'd multiply is 3 to the n minus 1 power. Now the bottom is a little bit different. Notice we multiply by 1, 2, and 3 to get to the preceding one or to the next one. So because of that, we know it's probably something with factorial. However, if I plugged in 1 factorial, that equals 1. 2 factorial equals 2, and then so on and so forth. 3 is 6. So one thing we've got to do is be able to get 2 1s. So to do that, what we could do is subtract 1, because we know that 0 factorial is actually 1 as well. So we could say this all over n minus 1 factorial, and that would be my answer there. Okay? Again, I'm hoping that helps. You could also on the top put 3 to the n power. You could do 3 to the n all over n minus 1 factorial. That could be the same thing as well. Okay? All right, I'm answering. There's a lot of questions being answered, which I think is very productive right now. Do you have any more questions at all? We could go through some. Trying to see if there's kind of going through here. Number 4, I just want to make sure. Let's actually, while people are texting in, want to make sure we're all clear on these. Number 3, notice if the sequence is defined recursively. Okay, what that means, and we can go over 15 here in a second. I'll be right there. But if a of 1 equals 15 and the sequence is recursive, that means I'm adding 2.5 every single time. So if I'm finding just a formula for the nth term and nothing more, what I can do is just do the a of n equals a1 plus n minus 1 times d, where d would be 2.5, a of 1 being 15, because that goes given. We could distribute 2.5 and then combine like terms to get what the equation is down below, okay? So just check that one out. And again, that's just what we're looking for with that one. All right, 15. Ooh, 15 is a good one. All right, sum of the infinite geometric sequence. Now, remember, infinite means that we're going to use our infinity formula, okay? Again, infinite. Make sure you make a note of this. A1 over 1 minus r is our infinite equation. The next part it asks for is, well, we just solve it. So a of 1 is negative 1. And what do we do to go from negative 1 to 2/3? Well, notice the sign changes each time. So as I keep progressing, it's multiplying by 2 on the top, and it is multiplying by 3 on the bottom. Notice, too, that this is negative. You could tell by the fact that it does alternate signs there. So we have negative 1 over 1 plus 2/3. 1 plus 2/3, this would be the same as 3 over 3, because we got to get a common denominator. Plus 2/3 gets me 5/3. Negative 1 divided by 5/3, we flip it, do the flip-de-flip to get negative 3 over 5 as my answer for the sum of the infinite geometric sequence in this example. Okay? Excellent. All righty, let's do 16. 2x plus y. Okay, that's a good one too. And that one's to the 4th power. Okay. Now, if I have something to the 4th power, one thing we got to know is what does Pascal's triangle say? So we have something that looks like this. And I think it's 1, 4, 6, 4, 1, right? So what we could do is these coefficients match up because it's to the 4th power. 4, 1. Now, as I go from left to right, notice that x is going to be to the highest power first, and then we decrease x to the 3rd, x squared, and x. Now, as x decreases, y will increase, so we'll have nothing, y squared, y to the 3rd, y to the 4th. Now, that's not my answer yet, right? We talked about this earlier because the 2x is representative of the first term, whereas y is representative of the second. So it should be 2x to the 4th plus 4 times 2x to the 3rd times y. The next one, third one, is 6 times 2x to the 2nd and y to the 2nd. And again, all I'm doing is just plugging in 2x to x and y to the next one, y to the 3rd. And last one is y to the 4th, okay? Now, again, all I need to do is just combine each one of these. It's a little monotonous, I get that, but it's not too bad. So you do the first one, second one, third one, fourth one, and then be able to add those together. Or if the one was negative, then you would make sure that you would put that negative with it as well. Okay. All righty. Let's see if there's any other questions. Do you have any other questions out there as we go through it? I'm going to hold off just for a couple more minutes just to make sure. Again, remember, sum of infinite geometric sequence. First 8 terms, you would use your calculator on number 4. By the way, plug this in. Same thing with 4a and b. Plug this in, go to second graph, and get that down, and it should be the same thing on that one. Did one of these up here on number 9. We were good there. Remember on this one that I is squared. So when you do that, you do this the same as what we were doing on this side. Right here, where are you? Right here, just make sure that when you plug in, I squared is -1. So just be careful on that. Sum of infinite geometric sequence, expanding binomial. We did that one there, touched on that one. 10th term. Kind of notice at the end that there are a couple problems, like word problems here, that you might want to focus in on a little bit. We did these in class, I remember, but these are good ones. This one right here would be the S of n formula. So what I'll do is let me give you the formulas here. This would be S of n equals n over 2 times a1 plus a of n, where n would be 25 and 12 would be like a1 because that's the first row. And then as you keep going, you'll notice you'll have to solve for this. So that's where you'll have to do the a of n equals a1 plus n minus 1 times d, that type of thing. Okay. So again, just kind of giving you a heads up on that. What are we looking for? And again, that's kind of what we're looking at there. These formulas over here, this one, some of a finite arithmetic sequence, similar. So S of n equals n over 2 times a1 plus a of n. Also similar, or kind of a little different, is it gives you what the sum is and actually asks for the last term. So you're going to be solving for a of n, or a of 10 because 10 is, or I'm sorry, a of 12 because 12 is the amount of terms that we have there. Expand, we did one of those. And we did all of these. We did a lot of these here. As we keep going forward, is there any questions that you have? And I'll kind of just keep holding off here. I'm going to make sure. Just a couple more minutes. By the way, happy studying tonight. Remember, you can put anything you want on that formula sheet other than examples. And I think that's it. Awesome. Well, hey, y'all. Care about you a lot. Hope all is well. Again, if I could help you out at all, come on in early in the morning. Remember, finish off spring break on a good note, okay? Finish off strong, and we'll go from there. All right, care about y'all. See ya.